Hello, welcome to Soil Mechanics Lab. We are going to do what we call the direct shear test. The objective of this test is to determine the shear strength of the soil under normal loads so that we are able to determine what we call the cohesion and angle of friction of that soil sample. Before you do this test, you need to first of all have done what we call the compaction so that you are able to get what we call the MDD or the maximum dry density of the soil, and also what we call the optimum moisture content of that soil sample. So those are what the initial steps that you need to have done. That is the compaction to be able to get those parameters, because those parameters, the MDD and the OMC, are what will enable you to be able to calculate the amount of soil sample required to fill this standard mold that we use for shear test. There is a formula which we use to be able to calculate the amount of soil to fill this mold, and also the amount of water that is required. So when you have done that, then now you can be able to proceed and be able to mix. So I'm going to mix the soil sample. I've already worked out the amount of soil sample and also the amount of water that is required. So I'm going to mix, to measure first of all the amount of soil sample required to be able to required for able to fill this standard mold. And from my calculations, I'm supposed to measure 210.7 grams of soil sample, and again I'm supposed to measure 18 ml of the water that will be used to mix the soil sample. The soil sample for this test has to pass sieve number 7. So I'm going to sieve this soil so that we are able to get what we are going to use for purposes of direct shear test. And this is what I have. This is now the soil sample, which has passed that sieve of number 7. So I'm going to measure 210.7 grams. This is my 210.7 grams. So the next thing that I'll do is to measure 18 milliliters of water. So I'm going to mix this soil sample with this water. We have these two perforated plates. One has to be placed at the bottom. So I'm going to place the first one at the bottom. Then for this two halves not to slide, I'm using the screw to be able to hold it in position. So I'm going now to pour my soil inside. And then I'm going to compact to ensure that all the soil sample goes inside the mold. Just like then on top, I'm going to position the other perforated plate, just like that. After ensuring that you have your the top perforated plate in position, you place this other plate which supposed to assist in distributing the load on the specimen at the top. Then the next step that you need to do is that you take your sample now and place it inside the direct shear box apparatus. When I bring the sample, I have to place inside this rectangular box, which is inside here. After ensuring that, then have to place this steel ball on top. So I'm placing the steel ball on top, and then bring now this what we call the hanger to rest on that steel ball, just like that. So this is what we call the hanger. After placing the hanger to rest on top of that steel ball, then we are supposed to load it 3 times. The first load is supposed to be 32.2 kilograms. The second load is 68.9 kilograms, and then the last load is 105 kgs. So I'm going to start with 32.2 kgs. So I'm going to load the first load, which is 32.2. That is 10 kgs. That is 20. That is 30. This is 2 kgs. And then this is 200 grams. So that is 32.2. So there's a startup that has to be done. There's this point here. There's a gap in between here. So I'm trying to bring this rectangular box to touch this tip here, because it is connected to this dial gauge. So I want to ensure that the moment I start my machine, it will be able to pick up. So it's already touched. I'm supposed to test under what we call the worst conditions. The worst condition is when you flood the sample inside here. So I'm going to pour water inside and give it about 1 minute or 2 minutes maximum to be able to take in the water before I now carry out the test. So I'm going to flood. This is what we call flooding. So as you can see, what is happening is that the water level, I had flooded up to the top complete, but now the water has receded down, so it has already taken in. So I'm going to top it up again. That is enough. The next thing that I will have to do is to engage the gear. There is a gear which I have to engage. So I'll just turn it this position. So I've already engaged the gear. And the next step is that before I start the machine, I need to remove these screws. This screws was only to assist us to be able to hold the two halves together. So I want to remove the screws before I start the machine. I also have to ensure that the dial gauge, the pointer is at 0, 0. After ensuring that everything is okay and the screws have been removed, then the next thing is to start the machine. I'm going to use intervals of 10 smaller divisions all the way like that until the sample shears. So I'm going to start the machine. I'm taking the second reading at 20 small divisions, which I have at 26.2. At 30 we have 13.4. At 40 we have 17.2. At 50 we have 2 complete revolutions plus 3.2. So the second dial gauge moves faster than the other one. At 60 we have 8.2. At 70 we have 12.4. At 80 we have 15.3. At 90 we have 18.1. At 100 we have 1.1. That is 3 complete revolution, then 1.1. (110) we have 2.8. At 120 we have 4.2. At 130 we have 6.1. At 140 we have 7.3. At 150 we have 9.0. 160 we have 10.1. At 170 we have 10.7. At 180 we have 11.4. At 190 we have 12.0. At 200 we have 13.1. 210 we have 13.4. At 220 we have 13.6. At 230 it's still at 13.6. At 240 that's it is at 13.4. At 250, 13.0. The process of getting the readings is done until at a particular point whereby you observe that the pointer has changed from going slowly to faster. Our sample has already failed, so the next step that we are supposed to do is to remove the soil sample from this rectangular box and then prepare another set of another sample ready to be tested with under a different load. So the first load that we did was 32.2. The next load will be 68.9, and then finally the third load will be 105 kgs. So I'm going to start by removing the weights. Thereafter, I'm going to raise the hanger. And then now be able now to remove my soil sample by lifting it up. I'm going to be able to lift it up like this. After removing the sample from the shear box apparatus, the next step is that you need to remove now that soil sample so that you are able to now position another soil sample ready for the next loading. So I'm going to remove this. After removing that sample which has already sheared, the next thing that you are supposed to do is you repeat the same procedure by again measuring the soil sample that is required to be able to fill this mold, also the amount of water that is required to be able to mix with that soil sample. Then you repeat the same process again, but now this time round you change the masses. So the first load was 32.2, the next one will be 68.9. When again that shears, you do the third one with 105 kgs.